Math operations. Now that we've had an introduction to whole numbers, let's look at the operations that we'll be using throughout the course. When we have quantities, we need to be able to put them together. Just as an example, let's say we had this and we had another quantity that looked like this. Well, there has to be a way to take these things and put them together. So we use the operation addition to put these together. So we would take this plus this, and that would give us this. So math operations give us a way to put things together. Now, in this case, addition is the base operation. Well, if you have the ability in math to do one thing, you go one way, if you will, then you have to have the way to go the other way as well. So if you can put things together, like with addition, then you have to have a way to take them apart as well. And that inverse operation for us is subtraction. And we use this symbol for subtraction. So if we can put two things together, then it makes sense that we should be able to take those quantities and take them apart. So we could use something like this and get this. That's subtraction. So notice, if you can go this way, then you have to have an inverse operation that will allow you to bring it back. That's a fundamental property in mathematics. Okay, so we have addition and subtraction. Now, another base operation we have is multiplication. And we'll use this symbol in the book. We'll also later on, I'll put this in parentheses, we'll use the dot. And that's to help us out when we move into algebra, so we don't get the multiplication symbol confused with the symbol for x. Okay, now multiplication. I ask students this in class. I'll say, what's the definition of multiplication? And I'll have the students say 2 times 3 is 6. And that's not a definition, that's an example of multiplication. Well, multiplication has a definition, and the definition of multiplication is repeated addition. So multiplication is just repeated addition. So if you look at this, it allows us to do larger forms of addition more efficiently. So just as we look here, I'm just going to do a basic one. Let's say we had something like this. We could add these together and get a 1 plus another plus another plus another plus, and we could keep on going, and we would get 12. So we could add 1 plus 1 plus 1 plus 1 and get 12. Now what multiplication allows us to do is to make addition more efficient. So what we notice is we have 3 by 4. So that gives us 3 times 4 is 12. So instead of adding 12 ones together, multiplication allows us to represent repeated addition, which makes things more efficient. Now, if we can take things and put them together more efficiently in terms of addition, then there has to be a way to take them apart more efficiently. So the inverse operation for multiplication is division. And there's multiple symbols that we'll use for division. And throughout the course we'll have these different symbols. Now, what's interesting here is if multiplication is repeated addition, then what's division? Division is repeated subtraction. So notice these connect here as well. So this is interesting because it makes subtraction more efficient. Again, let's say we had something like this. Let's see. I'm going to do a couple of rows of 7 here. All right, let's say we were going to take this quantity and distribute it among 3 people. Well, I could take one at a time and give one to this person, one to this person, one to this person, then one to this person, one to this, and eventually what we would do is we would have 3 stacks of 7 because there's 21 total here. Well, what division allows us to do is to take that 21 and divide it by 3 and get 7. So instead of doing them individually, division allows us to make this repeated subtraction more efficient. So throughout the course, we're going to be dealing with these 4 main operations. I will add in another just to show you. It's kind of interesting. Is if exponents, for example, we talked about earlier was 10 to the 3rd power. We know that to be a base of 10 3 times. Well, the interesting part here is exponents relate to multiplication because exponents are repeated multiplication. So this is a nice connection there. Exponents make multiplication more efficient. Multiplication makes addition more efficient. If we can put things together in larger quantities and make that more efficient, then we should be able to take them apart as well. And this is roots. If we took the square root of 10 to the 2nd, we would get 10. So this allows us to break things down more efficiently. Roots are nothing more than repeated division. So what you can see is here, see how this all interrelates. So the operations we work with, they relate to one another. And hopefully after seeing this diagram, this will help you moving forward, because the next part of the course we're going to move into using these operations and all the numbers that we learn about.